Hi, good evening. Good evening, friends. Um, Hello, wildlifers. Hope you are all doing fine. We, members of Rotary Fellowship of Wildlifers for Conservation, share a common interest, that is wildlife and its conservation, willing to work with the 119-year-old organization Rotary towards building a future in which people and nature thrive. To share a few notes about our fellowship group, we are a group of around 700 plus interested individuals who have globally united around a common interest with primary purpose to network and further friendship. Although our fellowship activities are conducted independently of Rotary International, they are in harmony with Rotary policies. Our purpose is to create awareness about importance of wildlife, to promote lasting friendships outside one's own club, district, and country, and to promote locally, regionally, and globally that conservation of living resources are important to humans and future generations to enjoy our natural world and the incredible species that live in it. Today, we have members from different Rotary clubs and friends of Rotary from different parts of the world for this meeting. A hearty and a warm welcome to each one of you. I am also glad to announce that our third chapter in Argentina and Latin America is active now, uh, ably headed by Rotarian Francisco from Argentina. On behalf of our wildlifers, I also extend a very warm welcome to our distinguished speaker, Mr. Ullas Anand. I request Mr. Vikram Hiresave to please introduce our speaker. Over to you, Vikram.
Thanks, Sanjay. Hey, everyone. Good morning, good afternoon, good evening, wherever you are around the world. Thank you so much for joining. And I'm very happy to be introducing Ullas today to all of you. You have a friend from over 3 decades, come on a talk and you're asked to introduce you. It gets a little difficult to choose what you want to say, but luckily Sanjay and Ullas have given me a ready script. I'm tempted to divert from the script, but I won't. Uh, Ullas Anand has been involved in building awareness towards wildlife and the environment for over 3 decades now, probably close to 4 very soon. And he's been actively associated with the bird watching movement in Bangalore. He was a key player in the midwinter waterbird surveys, which was one of the earliest citizen science initiatives in the entire region across Asia and Southeast Asia. And he's also co-founder of EcoEdu, and he'll probably talk about that in a bit. And he's been the founding moderator of the very first email discussion group on wildlife from India, known as the BNG Birds, which first came out on what eventually became Yahoo Groups. He currently runs one of the largest Telegram communities on wildlife in the region. He also organizes an annual meetup of bird watchers known as the Bengaluru Bird Day on October 2nd every year. And he's also the producer for the Bird Podcast, rated by Audubon as one of the top 10 bird podcasts from around the world. I sincerely encourage every one of you to listen to the podcast. It's an amazing hear every time, every episode of it. And his latest initiative now is a portal for natural, nature enthusiasts to share their field notes and trip reports on naturalhistory.in. So if you are a nature enthusiast in India and you would like to, record your observations and share it with the wider community, please do head over to naturalhistory.in and submit it. You can also look at what others have been writing. Finally, being a product designer by profession, he's been leading a dialogue for quite some time around sustainable redesign for product designers and architects on along the lines of nature-inspired design thinking, which is going to be his topic today. And his day job, you wonder where he gets the time to have a day job after doing all of this. But his day job is, he works as the vice president of product design at Typhoon, and he's done his post-graduation from the University of Wales, UK. Thanks so much, Ullas, for joining us today and, talking to us about this very interesting topic. I would love to hear more. Over to you.
Hey, thanks, Vikram. Am I audible to everyone?
Yeah.
Let me just share my screen.
Yes.
So today's topic is a little different from what you would have encountered in your previous talks. We're looking at design and how design can evolve by looking at nature, and there are great examples all around us, right? So what we're going to focus is more on nature and design and how it I mean whatever we have, what we use in our daily lives is inspired without us knowing it by nature on one side, and how we can use nature and just the progress is done by organisms over millions of years to inspire our own design philosophies and approaches. So let me just get started. Let's look at form and function. So when we look at nature, we're talking about helixes. We are looking at different types of geometries, and these exist all around us. It could be out when I say nature, it could be in the space, it could be in it could be on our planet, it could be an inorganic substance, it could be inside our own body, like the helix of the DNA. It could be anything, right? And even humans are also part of evolution. So you can look at our own form structure. So there's a lot of things that are inspired by our own form and structure, especially in architecture and fashion. So when you look at various things, helixes is one. You would come across spirals across different things, from the galaxies to a creeper going around, to how the sunflower seeds are arranged, to a mollusk shell, to how even tornadoes and hurricanes get formed. um, you could look at spirals with spokes, which are radiating out from a central point, like a spider web. Any of these structures which can hold things, when we talk about being load carrying, or even our nets, like fishing nets and things like that, follow very similar principles. And when we look at it, right? And we could look at different types of flows, different types of waves that are all around us, meanders, the huge starling murmurations, where the entire flock meanders across and moves across as if on a pattern. And you could also look at polygons, um, which form very good packing structures for occupying space. The most what should I say, adaptive and the most efficient way of doing packing as much of surface area as possible in a given area, right? And we have it in beehives, we have it in paper wasps, we have it across various different organisms, where we can see similar structures. And we are getting inspired by this every day, and we are looking at how we can take it into our everyday lives as well. uh, Before we go into that, let's look at habitats and how nature brought about some of these things over millions of years. So if you look at habitat is a place that supports life. I'm not going to go into details of everything because a lot of it is going to be repetitive to a lot of people. It provides plants, animals, and animals with food and shelter. It's not just a home; it's an entire group. You could think about it as not a single house, but the supermarket, the school around it, the workplace around where you need to go and make a living. So a habitat is something that kind of self-sustains a community, and it could very well be a microhabitat on top of a tree, where there's a small dugout and there's water standing there. It could be a large habitat like a biosphere reserve, like our own Nilgiris, or the Amazon forest, or any of the other bigger ones. Um, so if you look at it, we are able to build homes in all the different conditions, be it in out in snow, be it in the deserts, be it in forests, be it in clearings, wherever it is, in the urban setting. We live all over the world, and there's no place that humans do not live today. And there's no continent on this planet where we don't live. There is no habitat where we don't live, and we've literally occupied the whole of the planet. If you look at how we can change clothes, right? And we can adapt ourselves when it's colder. We can, get rid of clothing when it is, or wear additional layers. When it's hotter, we can get rid of clothing. And most of the animals and plants have evolved to specifically suit needs of their habitats and cannot change. And that's what gives them also the ability to develop adaptations which are very deep and unique for each of those habitats. If you look at India itself, why is India unique? Because we are a very big country with a lot of habitats. We have forests, mountains, lakes, deserts, rivers, a whole lot of habitats, and some of them are the biggest in the world. Like we have the tallest mountains in the world in Himalayas. We have, the largest delta in the world in the Sundarbans. We have, um, you know, um, a desert, which is a sand desert out in Rajasthan. The and you also have a salt desert in Gujarat called the Runs of Kutch. You also have high altitude deserts in Ladakh and Leh. We also have coral islands. We have a whole bunch of habitats. I'm just going to run through some of them: evergreen forests, the sholas and the grasslands in the Western Ghats. You have the moist deciduous forests. Pretty much spread through Western Ghats and Northeast. And you also have the dry deciduous forests across, again, uh, a large portion of the country, including, the central portion of India. You also have the open scrubs. Bandipur would come into mind, where you have open scrub forests. Bangalore would come into mind, where you have open scrub forests. Grasslands again, very common once upon a time, very transitionary in nature, disappears very fast based on the rainfall. If it rains too much, it becomes converted into a woodland. If it rains too little, it becomes a desert. Talking of deserts, we have sand deserts, we've got rocky hills. I'm just looking at habitats in India and showing a cross section of what we have. And we've got wetland streams, rivers. We've got mangroves. Like I said, some of the largest mangroves in the world are here. We also have a huge coastline, and we also have these high altitude lakes in Ladakh and Leh, where you have literally very little growing around, very little life, but then there's life which is very deeply adapted to living in those conditions. And talking about wetlands, coastal regions, we have a very large coastline, like I said, and islands as well, which lead to Bangalore itself, which has a lot of wetlands in terms of lakes, which are man-made, irrigation tanks, which hold a lot of water and supply a lot of water for human needs, but also support a lot of life. Talking about the coastline, our islands again, we have corals. Even in India, we have quite a large, amount of corals, which are seen here. We also have snow lines, where again, like I said, there's very scant vegetation, but then life is uniquely adapted to living there. Um, Talking about adaptation, I spoke about that. So what is adaptation? Where you have special features that suit that particular environment or the habitat that you're living in, and that is what is called as an adaptation. And there are quite a few types of adaptations that one can look at. It could be a trait, it could be a behavior. I'm not going to go into the technical details of what these would mean, but then you could have a plant like a cactus which can live and sustain itself in the desert region. You could have a behavior of a particular animal which is suited for a particular region. Like for example, the songbirds in forests, they have songs of particular amplitude, so that it gets carried for a longer distance, and they can sing across valleys to attract the mate. So there could be traits, there could be behaviors which are very different, and which are very well adapted to certain habitats. Let's take a look at some of the adaptations. I'm just going to again run through some of them. Porcupines, all of us know about porcupines. Hollow, modified hair into thorny structures, which we call as quills, which can injure you, gives a very protective layer to the porcupine itself. They've got very sharp claws, sharp incisors as well, and unique adaptation that is again well suited for climbing trees, well suited for burrowing. Again, a whole lot of things that we can look at and learn from in terms of structure and form and function. I'll come down to that in terms of how we take this into design, but let's look at a few more adaptations. Killer whales, for example, they have again, there are different types of evolution. You have divergent evolution, you have convergent evolution, you've got parallel evolution. So you've got multiple types of evolution that one can see. Um, in some cases, like the whales, animals that came onto land started going back into water, and the same shape that that fish and others have evolved to answer are the same things that they also evolved. And you can see similarities in terms of the fins, in terms of how their structure itself is. And you could also make out that some of this structure is also very similar to how a submarine and other things would look. And that's because that shape works. And there are some animals that have been evolved like eight to 10 times, and they have gone extinct each time and got re-evolved in the same shape, in the same structure, right? And you would see that pattern repeating often in nature. And you can also see that there are animals that belong to different groups altogether. Like, say for example, you have bats and you've got birds. Both can fly, both have wings. One has answered flight in a very different way by developing feathers. The other has membranes stretched across their digits. But then you could still find similarities in how flight works. And there are some parallel evolutions again, like for example the whales here in this case, and um, the fish itself. You have a dorsal fin, you've got large muscles, a broad flat tail. Again, these are animals that came onto land from the sea, lived here for a long time, probably evolved into different kinds of creatures. More dog-like creatures is what we think today, and went back into the sea again, into the water, and lost their limbs and adapted again back into a shape of the fish. And amazing stuff that we can see. Some of the adaptations, like the kangaroo rat, that can live for a long time without water. They have very large back, hind feet, which helps them move around. They can jump. They are very good in digging burrows. Um, a whole lot of things that one can see, which are physical adaptations. There are also physical adaptations in terms of, let's say, even the bumblebee or our honeybee itself, where you have got sticky hairs that can carry pollen. You have pollen baskets. They can collect honey. There's a whole bunch of things. They can do dances in terms of communication. So there's a whole lot of things that one can look at. The honeybees also, and look at how their communication without using verbal language, just visual communication, has resulted in a whole bunch of ways that we use similar communications to communicate with ships, with airplanes when they land. How you signal various things. Again, it's a whole bunch. It's a whole field called semiotics. Again, it's a field which looks at iconography, which looks at signaling, and there's a whole bunch of things that we can learn from things in animals and plants which have evolved various signals. Houseflies again. I mean, we've all experienced that. We can never try to swat a housefly, however hard we try, because they have some amazing adaptations in terms of how they look at time, how they look at movement, how they track what we are doing. So they literally are built for flight. Another animal that's built for flight are the barn swallows and the swifts in terms of birds. These are aerial, flyers. They have deeply forked tail, which gives them a whole lot of, control in the air. They can maneuver. They're, quite aerobatic. They actually track down and, hunt insects in the air. Birds like swifts, for example, they seldom land other than nesting. They hardly land because they don't even have feet adapted to, clutch on or hang on to a wire or a twig. So they are pretty much, aerial all through their life. And they fly around, they drink water, they sleep on the wing. Um, Amazing adaptations again. Owls, for example, have this very large dish-like, face, which is they're the only birds with front-facing eyes, like us human beings, and their ears are also slightly, dislocated. They're not in a straight line, so they can triangulate by sound, and they use their face like a dish, literally, to guide sound onto their ears. Um, their wings, again, their feathers are frayed. They don't, make much of sound when they fly. A lot of what owls, have as adaptation is what we use today in a lot of our stealth aircraft, military aircraft, and a whole lot of things. I'll come to some of those things as we go through, this session. Camels, again, we all know that they collect, store fat, and they can go for long distances without, water, because they reabsorb water. We've all heard about all these, amazing adaptations. Coming to what we, humans have as problems today, right? And looking very specifically to our modern day life, if we can look at, a cross section of, what we are looking at. Let's say we order food from a restaurant. We get a lot of packaging material. We order, anything, we get a lot of packing material again. A whole lot of waste that we generate. It could be straws, it could be, uh, anything, right? From a polythene cover to a face wash to you name it. And all our electronics with an end of life where you don't know what to do with it. And what are plastics? All of our plastics actually come from, natural sources. So if you look at, they're all byproducts of petroleum, and where petroleum started were, during the Carboniferous ages, our plants were non-biodegradable, right? Because of the complex polychain of, protein that they had, the cellulose, there wasn't any creature that could eat them. So they were pretty much non-biodegradable, and a lot of these forests sunk in, and that's what created, all the oil deposits in the world. And petroleum being, plastics being one of the byproducts of petroleum, it is what plagues us quite a lot even today, right? I mean, life has not been able to evolve to answer the question of, how to decompose plastics. But we are seeing examples of some fungi still being able to, look at plastics and, kind of degrade them, but it's still early stages. Let's quickly look at a small video about plastics itself. And
the plastics revolution starts with
Can
the
you hear the audio?
Victorian billiard ball. Since then, plastics have taken on a bewildering number
Yes, we
of
can.
shapes and colours. And they've changed our world in a bewildering number of ways. Not all of those for the better, a problem Sky's Ocean Rescue campaign aims to fix. It begins in East London.
These are the unlikely beginnings of the plastics industry as we know it today. In fact, it was kicked off by a Birmingham inventor called Alexander Parks. In 1862, he was responsible for exhibiting for the first time a commercial man-made plastics material.
And that was called Parkersine.
Well, I'm actually going to make some Parkersine under the watchful gaze of Professor Milo Schaff to make sure I get it right. And the first stage is to make some gun cotton.
It's a simple recipe. Mix sulfuric and nitric acids in an icy bath to cool the reaction. Then add a cellulose, in this case cotton. Stir, then leave to soak. After that, wash the acid off with a bicarbonate. Then leave the nitrated cellulose to dry.
So this is some previously dried out nitrated cellulose. To make it into a plastic, we've got to add a plasticizer like Alexander Parks did. In this case, we're going to use camphor and mix it with a solvent and hopefully get some plastic.
That leaves you with a dissolved plastic. Pour it out and wait for it to dry.
Pull it. Oh, and I've managed to tear it, but we have nonetheless synthesized the first man-made plastic.
Wherever you turn today, there's pretty sure to be a modern plastic in use.
In 1907, Bakelite, the first truly synthetic plastic, was invented in New York. By the 1930s, all sorts of new plastics were being created.
This paratrooper floating down to welcome Mother Earth is depending on plastics to get him there safely.
During the Second World War, parachutes were made from nylon, hand grenades encased in Bakelite, and the cockpits of airplanes were made from Perspex.
Here is a plane containing hundreds of plastic parts.
The war ended and the huge industrial plastic machinery was redirected at consumers. The living room was transformed, decade by decade, as plastics colonised our homes. By the 1960s, plastics was a big enough phenomenon to enter pop culture.
Are you listening?
Yes, I am.
Plastics.
Exactly how do you mean?
There's a great future in plastics.
And the world started to get a little more colourful and a lot more varied.
It also brought culture to a wider audience. Without plastics, we wouldn't have had film, which really brought theatre in to more people. We wouldn't have had recorded sound. I think that plastics has made for a much more equal world.
But then there was a shift. Durable, hard-wearing plastics made to last were eclipsed by throwaway, single-use plastics. From the 1980s, plastic bags and bottles started to become commonplace. Their popularity came at an environmental cost. Single-use plastics are the focus of Sky's Ocean Rescue Campaign for the damage they do to our waters. Plastics changed the 20th century profoundly. The job of the 21st is dealing with that legacy. Tom Cheshire, Sky News.
So one of the reasons why I
The
look at
plastics
the whole plastic problem itself, when we talk about design, you'll understand why it is such an important thing, because it's a design philosophy that we adopted sometime during right after Second World War, where we started replacing every single thing that we have with plastics around us, right? And it could be my watch, it could be my phone, it could be my headphones, it could be anything, and pretty much everything is made out of plastics today, and there's no going away from that. You look at material that was used earlier. If you look at cars, they were all built out of wood. If you look at airplanes, they were built out of wood. You look at pretty much anything back then. There were different designs that were evolved using different materials. Material science itself evolved because of the kind of freedom that plastics gave. And what do we do with plastics? We kind of reuse it, we recycle it, we kind of make roads out of it. But then it's just moving the problem and not really solving it, because even if you make the roads, it just disintegrates into microplastics, right? And all of it leaches back into the waters and into the environment. So you cannot really make anything out of plastic and hope that it will stay for a long time, because it will disintegrate at some point in time and you'll be left with junk. The same way, if you look at whatever we talk about, right? We say refuse, reduce, reuse, re-gift, repair, repurpose, recycle, and I'm just showing you from the preferred to the last choice as an inverted pyramid, how we look at it. We say recover. So these are all different things that we talk about when we talk about plastics. We say refuse, reduce, reuse, re-gift, repair, repurpose, recycle, recover, and then dispose, right? But nobody is talking about the top of the funnel. The top of the funnel is redesign, right? Nobody is talking about why can't we look at redesigning what we have as whatever material we use, whatever technologies we use, and how we can do it better. Some of it, like for example, some of it, like for example, most of the things that we consume, there is a technical life cycle, right? And most of it goes into what we call as a cradle to grave cycle. So I use my phone. At the end of the life cycle of this phone, I throw it away. It goes into a landfill, and that's the end of it. Maybe the company takes over some of the components, some of those things they extract out, but a large portion of it still goes into the landfill. Now, when you look at anything biological, when we look at even us as human beings, right? What happens to us after we die? You know, we are either buried, we are either burned, we somehow we are returned back to nature, right? And there's a cradle to cradle, as we call it. Whatever is the grave of one of the organisms in nature turns out to be the cradle of another organism, and that's what we call it as a cradle to cradle rather than cradle to grave. And that cycle is very important. So if you look at production, product, use phase, biodegradation, biological nutrients, this could be anything: vegetables that we use, plants, plant material that we use, it could be a wooden table, any of those things. There's a definite returning back to nature kind of a cradle to cradle system. And very similar things can be adopted in technology as well, where the product itself can be disassembled, reused, the components could be reused, or the technical nutrients can be taken out, as we call it, and reused in production. So there's a whole lot of thought being put in by EPA in terms of how we can do a technical cycle which can go from cradle to cradle. And when we talk about biomimetics, biomimicry, nature-inspired design, I like to give this example. So when you look at a Batman and a Spider-Man, a Spider-Man got bit by a spider and literally turned into a spider, and was able to shoot webs and everything else. Whereas the Batman, is a normal human being. He doesn't have any superpowers. Pretty much everything that he has built around him, all the gadgets that he has are adapted to a life in darkness, and that's what makes him Batman, right? And so when we look at it, we're not looking at literally translating whatever we see in nature into our lives, but we are looking at inspiration from nature so that we can adapt it into our gadgets and see how also it can be made into a sustainable design. So when we look at how we got encouraged, one of the biggest things is flight. Pretty much all our flight has been inspired by seeing birds, bats, and other things fly around. And it has been one of those things where humans have taken to flight because of looking at various aspects of flight around us. From Leonardo to everybody else looked at how to fly, and we've been rethinking the same question as to how humans can fly for a long time. Some of the popular examples I'm just going to run through again. You would have seen this, you would have heard about these things, so I'm not going to delve a lot into these things. The Kingfisher, the observation of the Kingfisher going from one medium to another medium, and the bullet train in Japan, when it used to enter the tunnel and exit out of the tunnel, used to cause a sonic boom. So the designer of the bullet train happened to be a bird watcher, and he designed the cone of the bullet train to be like that of the beak and the forehead of the Kingfisher, to cause less resistance when it moved from medium to medium, thus reducing the sonic booms and making it more efficient, fuel efficient as well. So it's a very well-known case study. You can read up on it. Gecko tape, again, non-adhesive tape. When we look at the feet of gecko, there are small hair-like structures which again exchange molecules. We always think these as suction pads that help a gecko walk on the wall. It really is not. These are small little hair-like structures that help the gecko by exchanging molecules between its legs and the wall. Van der Waals equation, as we call it, Van der Waals force. And today you have very similar, very microscopic hair-like structured tape called gecko tape, which is non-adhesive tape, which can again hold a lot of weight. Tokyo Subway, when they were designing the Tokyo Subway, they looked at mycelium fungi, and this is Tokyo. This is their main station. They put a piece of bread in each of those stations, and they infused the central portion here with mycelium. And they saw that how the mycelium grew and occupied to infect the rest of the the substrate. And they saw how the lines started developing between the stations, and they found the least path of resistance in terms of how the design can be done. And today, Tokyo subway is pretty much designed looking at this structure of the mycelium, right? And how it developed between the stations. So you can again look at how to cut down costs, how to optimize material, a whole lot of things. And inspiration can come from anywhere, right? And you have the birds, the when you walk in any grassland, you'll have these, the seeds of the grass stick to you. They have these small, tiny hook-like, things. Velcro was made almost 100 years ago. Looking at them, so Velcro is pretty much used everywhere. We use it in all our bags everywhere, right? And one of the most ubiquitous design, again, made from something that we observed. The fin of the whales and the small little, the projections there, they cause almost, when you look at a whale swimming in water, they modeled this in air tunnels and in various other places, and they found that there was almost a 30% efficiency in terms of how whales are able to manage moving through water. And today you have whale power and a few other startups which are looking at making wind turbines, to turbines itself, very large scale turbines, looking at the fin of the whale, and they're reducing costs. They're able to output more energy as well, generate more energy both in water turbines and in wind turbines. So there's a whole lot of research in terms of how whale fins have resulted in turbine design. Again, like I said, very disconnected. It's not directly looking at how a whale fin can be used for to swim in water, but again, looking at different medias and applying those things. Things like the lotus leaf. If you look at it, most leaves have this adaptation where they kind of are water repellent. Some have different structures. They have waxy, leaf, structure itself. Some, like lotus leaves, have these small, tiny hair-like projections that don't even allow the water to stick along. They make it look like a pearl, and they just throw it out along with all the dirt and everything else. And today we are having exterior coating. You would have seen advertisements in TV saying after even 10 years, my walls still look the same. And they've all licensed this patent from Lotusan to actually, have it incorporated within their, outdoor paints. So the outdoor paints that we use today, most of it actually have these small, little, tiny microscopic hair-like projections, which don't allow water, don't allow fungi to grow on them, don't allow algae to grow on them. So you have pressure walls and long-lasting colors, and and even the dirt gets washed away, right? So you would have seen all the ads in all TV shows. Another very famous and very well-known example is the termite mound, and how you have the convection current of the air, warm air going up, and the cool air sinking down, setting a cycle. And the Zimbabwe East Gate Center in Harare actually uses the same technology. They don't have, in the middle of Africa, they have no air conditioning, and still are able to run an office space without any air conditioning. Pretty much completely cooled by airflows and currents that are generated through ventures and through convection current principles, and many more, like how bees are there. You have colonies that are built in the same way, pods that are built in space the same way. I have a friend whose PhD work was on looking at underwater creatures and looking at robots designed to move on the seabed, using a similar kind of locomotion as underwater creatures. So what next? When we look at design, and when we look at, let's say, a standard design thinking process, we have these steps. This is the same old wine in new bottle, whether you call it human-centered design, whether you call it UX design, user-centered design, or design thinking. Pretty much they all talk about the same thing. You empathize, you define the problem, you look at ideation, whether you do contextual inquiry, whether you do whatever you do to do empathy. You look at personas, you define your models, you define who the people are, Then you share ideas, you do prototyping, you test the prototype very quickly. If it doesn't work, you go back and you again, relook at the cycle, right? And this is what we more or less look at it. And how can we bring nature into this design process is by looking at, a nature-inspired design inquiry in the ideation stage, where we can look at, are there ideas in nature that are worthy for us to look at, whether they diverge or converge, or whether we can use some of these ideas, and how would those ideas work by prototyping them, looking at storyboards, failing fast, and again going back and looking at other models. And these are possible not just for physical products, even for software. There is something called ant colony optimization, ACOs, that are quite often used for looking at paths to through databases, through graphs, through various data structures. Again, they looked at ants, how the ants move around, and looked at uh, probabilities around those to come up with ACOs. So similarly, you could have quite a lot of things, and one surefire way of looking at that is to look at this website called asknature.org, wherein you can go and query for anything. How do you do a certain thing? How do you do packaging? And there's a whole bunch of things on how nature has handled packaging. How do you do waterproofing? There's a whole bunch of results that you get how nature does waterproofing. Look at our coconut, right? I mean, the coconut is a floating device, completely waterproof. It floats on seawater, but has fresh water inside, has a hard nut inside, protects it. There's also fresh water that sustains the seed till it reaches the shore. So there's a whole bunch of things. There are people who are looking at helmet design, looking at woodpeckers' heads. There are people who are looking at packaging, looking at coconuts. There are people who are looking at packaging, looking at silk cotton trees. There's a whole bunch of design that is happening today in the world, where a lot of people are looking at design inspiration from nature to seek these answers. And there's a very big movement on biomimetics started by Jenin Benias, and biomimicry.org is a great site again for people to download small booklets, study material to get started on this. I know of people in Bangalore, for example, who are looking at soaps, being given in self-dissolving pods that do not require a soap, like standard soap design. So they would be like the pods that you take when you run a marathon. So you would take the water and you just put that entire pod in your mouth, and that water goes in. So they're looking at similar pods, which are like a single-use soap pod, which you can use, and then it just dissolves. And they're looking at eco-friendly material for that. They're looking at eco-friendly soaps, surfactants, a whole bunch of things that are happening even in Bangalore, based on this entire thing. So yeah, that brings me to the end of the session itself. If there are questions, I'd be happy to answer.
Wonderful. Thank you so much, Ullas. I think you have really inspired us to think and see what we can emulate from nature. Yeah, over to the audience for question and answers. Questions? Yeah, myself and Vikram will moderate. You can raise your hand, or you can type your question in the chat box.
Bharat
Please
has
go ahead, Bharat.
Yeah.
Thank you for a great talk, sir. I just wanted to know, how optimistic are you about the future, the overall future of the planet, given all these issues?
Yeah, I mean, I think living on Mars and other things are very far-fetched. I think even small things like breathing air and drinking water becomes very challenging there. Instead of solving those issues, I think we are better focused to look at problems that we have and solving those. That's my opinion, and I think there's a whole lot of effort being put in. I'm very optimistic. There are two ways of looking at it, right? And one is glass is half empty, one is glass is full. the half full, half empty. The other aspect is it's always full. It's half filled with air and half with water. So you can look at it in multiple ways, but then there are people who will look at it from a very doomsday kind of a perspective. But I think there are a whole bunch of things that are very positive. When you look at it, there's a whole bunch of designers who are looking at changing the way we do things, and I'm very positive. And unless we blow ourselves up because of our differences, I think that's the only thing that probably comes in our way. But I think if we can change our lifestyles a little bit, if we can redesign what we are bringing in, and especially product designers, if they can look at redesigning products, I think it would be, because people will buy anything that's advertised, right? End of the day. If you can redesign it and make it into a thing that is not as harmful, probably that's the way forward.
Thank you, sir.
Yeah, Rotarian Jalaluddin Khan from Rotary Trinidad and Tobago.
Thank you very much, and pleasant good morning from our side of the world, and also thank you very much, our speaker. I just want to take off from the last question and the issue that we live in a capitalist economy model and reverse engineer our design thinking, especially in terms of green design thinking. And speaking as a designer, we have 3 points that I'm concerned about that you comment and then ask question. That on one, if we reverse engineer, we have the consumer who's either accepting or challenging what is being given to them. In the middle is the industrial designer who's designing the product. And on the end side, which I want to focus on, is the industrialist or the investor or the person who's actually making the investment for mass production of a particular product. And this is the concern I have at three levels. One, could we think about design thinking, especially our industrialists and our investors, about green design as being accepted? In the middle, that our engineers and design training to be more eco-design in that design, and our consumers to say, no, I am responsible in terms of what I consume. And we see this happening in, let's say, in different regions of the world. In Scandinavian countries, they have gone green design, they go to consumer, the designer, and the industrialist. But I think there's a whole mass capitalist market thinking that we have consumers in different regions of the world, be it Asia, be it South America, etc., who are consumers, and they're capitalist thinking that we just want mass consumption and profit margin on it, and the compromise of not being, for the environment is pretty much for profit interest. I'm not concerned with that because certain regions may not have industrial standards and environmental standards. It's like the clothing industry of rayon and so forth. It's not necessarily in the first world country. They're producing the stuff, they're taking it to other regions where the pollution impact of the processing is not looked at, for example. So I just want to have your thoughts about that, about both. Do we have to work on industrial investors, developers, because the world is becoming smaller and smaller into mega companies, and really work on our designers about being ethical about environmental and eco design, and also our consumers to educate them that we want green design products. Thank you very much.
Yeah, I mean, I think it's a great observation. Companies will always try to extend their life cycle, a product life cycle, by going into other geographies where that same product is not available, but then they're coming into that market 20 years later. But it's got the same inherent problems that have resulted in bans in the places they originated. And unfortunately, we do allow such goods to come in. There is a way of looking at it, right? I mean, if you look at even the UN, they have the SDGs. They've got a whole lot of things defined in terms of why somebody should be doing more sustainable products, more sustainable development goals. But then the problem is also that companies tend to kind of expand into geographies, and that's one way of sustaining themselves. One could always say that like how we've leapfrogged from older technology to newer technology. Like nobody in India would I mean, we skipped a generation and we went directly to mobile, right? So nobody in India would go back and say I would go into a PC and there would be this PC versus Mac kind of a battle all over again. So like we've adopted technology that is more modern, be it UPI or ISO 20022 standards or whatever else it is in terms of financial payments, where even today America finds it very difficult to move money on the same day. We can do it instantaneously. We should again adopt newer more sustainable practices and goods rather than go back 20 years and use the same goods that have those inherent design flaws. And that comes from encouraging design schools in our own countries to look at alternatives, to look at design in a positive way. And I think the biggest contribution that we could do is like I said, in all those R's that we looked at: reuse, refuse, whatever. The biggest thing that we should look at is redesign, right? And if you can redesign and bring that thought into our own designers and our own design faculties, I think that would be a great way to do this. And nobody is saying that an eco-friendly design is not profitable. Being capitalistic, it need not be charitable. It is extremely profitable. It is still a business. It can sustain itself and make money for everybody, including the investors.
I think there was a question. Rajesh Kundar had raised his hand. Would you like to ask? Otherwise, I can ask one from the messages.
Yes. Can I?
Please go ahead.
Yeah. Ullas, it was a wonderful talk and very inspiring. And I have a little different perspective being a product designer, having spent a good couple of years working on in the lines in the faculty of design thinking. What I'm wondering is, I noticed that almost all the products that we have designed or we have been using as human beings are almost all imitated from the nature, like you have rightly presented. Now, each of these organisms that are existing, the nature has designed them, or nature has produced them with an objective, clear objective. Similarly, human beings, with all their accessories that they are designed, like the length of the hands, the length of the legs, and all of the ability to see the distance, ability to hear, all these capabilities are provided to human beings as a clear specification for achieving some objective. Now, these features that we are gifted with, I think we are misusing it by imitating poorly the nature. And what are we doing? We are just trying to reinvent the wheel, a wheel which is already sophisticatedly designed already by Mother Nature. And by doing this imitation, poor imitation, what are we finally going to achieve? I mean, with so much of products designed in so many hundreds of years, I've seen that these poorly designed products that we call are destroying the good design of the nature. This is my thought. You can give your impressions, please. Thank you.
Yeah. Rajesh, very, very rightly said. And I think poor design is what is plaguing all of us, right? I mean, it's not. So see, there is a way of stopping the leak. One is you go on patching the leak wherever there is a leak. The other is to stop the tap, which is pouring in water, right? And that is the design. Those are the designers. That's the poor design that is bringing the problem and moving the problem to somebody else to say that, hey, you know what? Now we have a lot of these things. Now handle how you want to recycle, how you want to dispose of these things, right? So I think when we look at imitation, like I said, the difference between a Batman and a Spider-Man, right? And when you look at, do we really want to become a spider, or do we want to look at how a spider uses various things to adapt to our own life, and how much of that do we want to go in as a design philosophy is something that we'll need to look at, right? And it's a very slippery slope for designers. When we say nature-inspired design, they would look at making a plastic plant, an indoor plastic plant. That's also nature-inspired design. I mean, you're exactly bringing nature into your into a design form. But then that's a like you said, a poor copy, right? And it doesn't add any value. It's a poor design. All our indoor plastic plants and whatever else, right? You would rather have a living plant, but then they still sell. plastic flowers, plastic plants, you name it, right? And it's whether you're mimicking it directly one to one, or you're getting inspiration from that and looking at that inspiration and adapting it to your life. And again, poor design, good design is it. So long as you stick to the base principles, you're doing cradle to cradle. You're not doing cradle to grave. You're looking at what happens end of life in terms of planned end of life for products versus non-planned end of life for products. You're not looking at making a quick buck, but you're looking at a sustained economic impact. You're looking at bringing about changes, looking at changing industries rather than selling products. That's when I think it becomes more meaningful.
Okay, thank you.
Thanks, Vilas. Thanks, Rajesh, for a wonderful point. I guess evolution takes longer than humans take to copy, so that's probably one reason. Hi, Jalaluddin, you could go back. Actually, just before that, Jalaluddin, if you could just wait a moment, I'll just take Madhu Reddy's question. I'm not sure I fully get it, but I guess Ullas would. Ullas, Madhu has a question. He says, with regard to social community design, you mentioned ants and bees. For human social design,
Vikram,
which examples?
Vikram, I think Madhu
okay.
has raised hand.
Great. Madhu, why don't you go ahead?
Yeah, so thanks for the session. You had mentioned we could learn from, bees and ants, but it's a very hierarchical hierarchy that they have and how they work, right? So I was just wondering if there are any social animals who are close to how we behave, and how can we design our communities to kind of reflect that? Anything that comes to your mind? I was wondering about that.
So bees and ants and these eusocial animals, as we call them, they have a genetic adaptation that makes them eusocial, meaning for us, progeny has 50% contribution from both parents, right? And in these cases, the queen or the breeding female contributes 75%. Of her genes, right, versus 25% from the male. So that's why they tend to kind of behave differently. And there's also there's a whole bunch of studies in terms of why eusocial animals are eusocial. We do have primate societies. We do have which are similar to us in organization. At least the basal us versus the more refined culturally evolved us. But then rather than looking at these ants and bees for our societal organization. By the way, ants and our corporate world pretty much morph each other. They mimic each other quite well. So you have an incumbent and you have a role, and the incumbent goes out, gets killed in an ant. Let's say they get trampled, they get preyed upon by some other predator. There's a replacement that takes over the same duty, right? Same in an organization. You have an employee who quits. There's somebody else who's roped in, who's recruited to play the same role. The role remains the same. The person who plays the role changes, and that's how ant colonies work as well. And more than that, what people were looking at is how are ants efficiently being able to organize themselves into lines. So that brought about, let's say, the Southwest Airlines, how they made their queues, self-organizing. Ant colony optimization, like I was talking about, when you go into search engine algorithms, when you go into some of these, database optimizations, you would see a lot more, patterns that are, kind of repeating. And there have been a lot of papers written about how to query databases using things like signals and things like that, which are more esoteric and comes from an ant or a bee world of pheromones and things like that, of locating signals and locating, and that becomes more increased in terms of the scope and value with AI and everything coming around, and how decisions are made, how generative algorithms work and a whole bunch of things, so which are again very mimicking nature, kind of a way of thought, including our brain. But then, yeah, I mean, social structure-wise, they are very hierarchical. You're right. But then each individual has a role. There are nurse ants, there are major workers, there are minor workers. There are the queen, multiple queens in some species. There could be multiple males in some species. It depends, how you look at it. We follow similar structure. We have rulers, be it elected ones or selected ones, or higher, or people who have descended from various dynasties. But we do have leaders, and then we have followers who are all us people trying to live our lives. But then it's a similar structure. Corporate structures follow the same thing. Pretty much any top-down structure follows the same similar kind of a hierarchical organization, where there are selected few people who control the hive or the collective mind of an organization, and rest of the people contribute towards how the organization itself behaves, how the organization itself responds, and we call them as corporate culture, right? And that's not normally how we model ourselves. Did that answer your question?
Yeah, it did, but I mean, it's just that it's I guess it doesn't translate to a very equal society that you want for humans. But yeah, I was trying to see if there were better corporate structures, better social structures that we could learn from, right? Where it is everybody's voice. I mean, in democracy, it's not everybody's voice. It's only the majority voice, and that's whatever number of votes you win by, but 49% is still saying no to something. So that's where I was wondering if there was anything in nature which is a lot more sociocratic rather than hierarchical or democratic. But it's just a thought. Anyway, thank you. Thanks.
Yeah, I don't think there's anything like that in nature. Everything is, very a top-down hierarchical structures. And in some ant species, by the way, every single born individual is a fertile female. There are ants which grab hold of that female and they surgically remove, the reproductive organs to make them drones. So you could go and make them workers, right? And you could go into equality and all those things, but then nature works in a very different way. And I don't necessarily know of anything which is very equitable. Even in elephant societies, large herbivore herds, again there are pecking orders. There are different controlling matriarchal societies. There are different controlling alpha males. Again, very brutal, very different world. And we are also animals, by the way. End of the day.
Thanks, Ullas. Thanks, Madhu. European discussions, but hopefully reality someday. There has been one more question from you. Then I have a couple of them.
Quick one. As fellow Rotarian, we are leaders and we are influencers, and our organization, one of our 7 pathways is environment. And I just want to focus on the, what is the majority of our landfills is what goes in our majority of our landfills, packaging waste. And many countries, through environmental policies, they have looked at, the policies to control waste generation. Could you, from your part of the world in India, is there any, I'm looking at the political thinking of design and environmental green design. Is there any policies where, from a state level, have identified to industrialists and manufacturers, we have to curve back on product packaging, over packaging, and also to have you, from your practice as industrial design, look at green packaging, which we were, when we were children, were growing up, we're familiar with, natural product versus plastics and paper products on over packaging. So just a thought about those things. Political thinking in terms of green design thinking as a society, state level or industrial level, and also to as a in designer, redesigning new packaging and reduction. Thank you.
Yeah, I think there's a whole bunch of thought around packaging design itself, and we're seeing even Amazon and a whole bunch of other bigger industries change their packaging practices. One of the things that I saw in the US was when I ordered from eBay from a small seller, individual seller. She sent me, whatever I had ordered in a box which contained popcorn, right? And that was the packaging, right? Instead of, and she sent by the way, a small sachet saying that this is a tastemaker. You can put it and mix it with the popcorn and eat it. It's food grade. So I literally ate the packaging, after I ordered the whatever was that, electronic item. So there are possibilities. Certainly there are possibilities, and it takes a bunch of people to bring about the change. And those people are all people, here and out in the industry, right? And each of us control, the design philosophies and, how we look at corporate structures and profits in our own companies. And how we can bring about changes is all up to each of us individually. And some individual decisions will have very, very far-reaching, impact. And you'll be surprised how a simple thing like, using popcorn as packaging versus, bubble wrap can go a long way. And, it can create a big impact. I mean, I still remember, that seller and, how I received that package. This was almost like 20 years ago. But then, there are people who are still innovating. And I know design schools in Bangalore who've been innovating quite a lot in terms of packaging design itself. They're looking at, like I said, coconut. They're looking at, a whole bunch of fiber. They're looking at a whole bunch of coir. They're looking at silk cotton, in fact, and looking at, how silk cotton, which is not used in anything other than pillows and soft toys, can be used as packaging filler material. And there's a whole bunch of study on all those things. Garment, I think, garments are the same, irrespective of which country we talk about. And, it's difficult to move them unless there is a voice and a majority representation. And it's difficult to look at change from policy versus, bringing about change in terms of industry. I would always think industry is easier than policy. And I mean, going back to what I think Rajesh posted, right, about why should we even, fly at all, if we are not meant to fly? Absolutely, I totally agree with your opinion. I think if we were meant to fly, we would have had wings. But unfortunately, we do look at our brains, look at, adopting various things, including why should we wear clothes? I mean, that's a very good question to ask, right? I mean, we do wear clothes because, we need to protect ourselves from our environment and live in different environments. And yeah, I mean, we do wear, woolen clothes to, bathing suits to swimsuits to everything else. And everything is an adaptation. And we have adapted those things as practices because we can build tools. And we're not the only ape that can build tools. There are other apes that build tools as well. So any tool making organism would try to adapt and bring in practices from other, organisms.
Thanks. I think there's a question from Harsha. Harsha, would you like to ask it yourself, or we could ask here? All right, let me go ahead and ask the question. He said, Ullas, in your, and study on how do you think people perceive these various designs as consumables? I think Sanjay also expanded on that, saying, what has been your study on how people perceive these various designs from a consumables perspective?
Yeah, I mean, consumables, again, there's a whole bunch of, I'm understanding this as consumables, as in products that we consume and use, versus things that we kind of treasure and persist with for a longer time. I hope we are talking about the same consumables, because in industry, consumables mean a very different thing. I don't know whether that's the question. Harsha is still on; he can clarify. But then, Harsha, was that the question? Are we talking about consumables as in things that go into a product as consumables, or things we consume?
I
Yeah,
guess
I
he
mean,
means consumables, not the popcorn variety for packaging, but more of consumables like paper and ink, probably in printers.
Yeah, like I
as an
said, there are
example.
people in Bangalore who are doing soap design, right? And these are, so what happens with your soap bar is that the fragrance stays only for the first few uses. After that, it pretty much becomes, not so fragrant, right? I mean, it starts losing out the fragrance as you use it. And these are people who've been in the industry for multiple decades, doing, leading very big consumable companies. And these are people who are in the quick consumable categories. And what they're trying to do is to see how they can build things which are single-use consumables, which dissolve, uh, disintegrate, and completely decompose after that's one single use. So you have, think about it like, you had those paper soaps earlier, which people would use, where the paper itself would disintegrate after you wash with the soap. But then think about that. But then think about it more eco-friendly, more sustainable packaging. And we are talking about similar things. Like I said, people who run marathons, they use water pods similar to that, which they just pop into their mouth, which comes with a almost like a plastic, like packaging, right? But then they don't use water bottles anymore. They don't throw bottles around anymore. So you could look at even water being sent out like that. For all that it matters, soft drinks. Why can't we just go back with the bottle and refill it? Why don't we have refilling stations? Is the question, right? I mean, so you can have a Coke, fountain, or a Pepsi fountain, where you go to a McDonald's or something else. You have those machines which give you in a cup, but then they still sell you a can. So why can't I go back with a packaging which is reusable, where I buy, if I don't go back with what I already have, the cost is different, whereas the cost for refilling it is very nominal. Then you encourage automatically behavior where people would consume things by taking back what they already had, right? I mean, like refilling a water bottle, very similar to that. So there is a whole bunch of movement along those lines as well, where people are trying to build and design consumables which are single use, which kind of disintegrate and decompose after that use, rather than contributing junk. And people have been doing it for shampoos, right? You don't have to buy a shampoo bottle and throw the bottle. You can buy a package of pods that you use each time, and then after that there's nothing left. So people are doing a lot of those studies as well.
Thanks, Vilas. Any other questions? I don't see anything on group, the messages either.
Yeah, and Sugandhi, I think, also said, bring your own box or bring your own bottle, which is exactly what I'm saying. I mean, so you take back something that the company has sold you, and take it back to them, and they would refill it at a nominal cost versus reselling you with the packaging all over again.
Yeah, Bharat. Yeah, please. Go.
Would you be in favor of banning bottled water?
Yeah, I mean, if we can provide water, in a way where it can be consumed safely, access to safe water, consumable water is provided, I don't see a reason why bottled water should even exist. As a category, by the way, bottled water itself is a negative demand product. There's a whole history behind why bottled water became bottled water. Very interesting to look at it in terms of how it was sold to people. Why they said all water that you're drinking is bad, can give you, various illnesses, versus, I mean, we've been drinking water for thousands of years, multiple hundreds of thousands of years. None of us had bottles back then, right? And so it was a negative demand product that was built on fear perception of people to say that, we need bottled water, right? And in a lot of cases, actually drinking from the tap is much more safer than, buying a bottle. So long as access to safe drinking water is provided, bottled water should not even exist as a category.
Thank you.
Yeah, thank you. I think we have no more questions. Thank you so much, Ulas. It was a fantastic session. A lot of messages appreciating the talk, and was totally different from the rest of the talks that we have had. Chris wanted to say something. He's from the Rotary Action Group for Endangered Species. Of course, he has put in the chat box. He's here. Yeah, Chris, over to you.
So thank you so much, Sanjay. It's nice to be here with this meeting. I really like joining with the Wildlifers. So the Rotary Action Group for Endangered Species is having a booth at the Rotary International Convention in Singapore. I'd love everybody who is going to Singapore to contact me and let me know that you're actually going to be there, and come along to the booth, join us. If you've got some time, obviously we'll have spaces in for occupying the booth, talking about the things that are there. We will have a small note directing people to Wildlifers, and we'd love to encourage people to join Wildlifers and also to join with Ragers as well. So please, if you're going to be there, contact us so that we know that we have a contingent of members of both organizations, Ragers and Wildlifers, present. So I know that Wildlifers doesn't have its own booth, and so you can share with us. And we'll have a QR code so that people can connect with Wildlifers directly from our booth. Thanks so much for the opportunity, and it's great to hear this program today. I really enjoy having the meeting on the 5th of every month. That makes it really very easy to coordinate, even if it's a weekend, even if it's Sunday morning at 4 a.m. for me. So thank you, Sanjay, and Ulas for the presentation today. Great.
Thank you, Chris.
Thanks for having me. Yeah.
Thank you, Chris. I will. There are quite a few members who are visiting the convention. I will definitely coordinate with them, and I will ask them to get in touch with you. Thank you. So thank you, Ulas. Thank you so much for accepting my invitation and coming. And thanks, Vikram, for introducing Ulas. I also thank all the members who have joined today and all the guests who have joined today. We had members from Trinidad and Tobago. We had members from Germany. We had, of course, a member from the new chapter, the president of the new chapter, from Latin America. Ulas told us very interesting things about different habitats to adaptation, and how a bird watcher, created the bullet train design, about the Velcro, then the Eastgate Center building. It was really fantastic. A lot of learning from Ulas. Thank you so much, Ulas. Thanks for this choosing this wonderful topic. I'm sure we'll have one more session from you. That will be a topic of my choice. I will soon come back to you on that. Okay.
Sure.
Thank you all. Thanks for joining.
Thanks, everyone.
Have a good evening, good day, and great weekend.
Thanks, everyone.